Thank you, Pierre Louis, to introduce me and also Roland before. Today I'm here from my award, so I will talk about the paper which microorganisms contribute to the mousy off-flavour in our wines. And so it's in British English, not in United States. And so I've done my PhD between Geisenheim and Bordeaux, as said Pierre Louis. And I will talk a bit about my PhD project because it was really the first paper from this project. And I worked on the exploration of the phenomena associated with the production of pyrrole and pyridine derivatives responsible of the mousy off-flavour in wine. I've been supervised by the Dr. Patricia Balestra and the Professor Doris Raoult. I was also supposed to go to Adelaide, but unfortunately, due to some paper issue, I've not been able to go there. So as you all know, the wine is a complex matrix with a lot of different aroma coming from grape, but also from the fermentation and the aging. But we can also find other aroma as a defect. A defect, according to the Cambridge Dictionary, is a fault or problem changing the property of the wine. So in the wine, we can find several different defects as ethyl phenol, oxidative nodes, but also some reduced nodes. But we can also find some mousy off-flavour. The mousy off-flavour is on the rise for a few years now. We're saying few years, but it's more than 20 now, but still. And we are saying that putting two cores on that, the consumer is asking for less nutrient in his wine because he's wondering is taking care of his health and everything. So he's asking for less nutrient in his wine as the SO2. And as you know, the SO2 is used in Enology for his antimicrobial and his antioxidant properties. But the consumer is also asking for less nutrients. So we are using more endogenous flora. As they talked before, there is also the climate change, which are increasing the pH and increasing the sugar amounts in our wines. And unfortunately, all these elements will increase the risk of microbial spoilage in our wine and the risk of a mousy off-flavour apparition in our wines. And as you can see, the mousy off-flavour has been described in several countries as United States, here in California, South Africa, but also Australia, Europe, and also Asia. So to talk a bit about the mousy off-flavour, I want to make what is the mousy off-flavour? The first time it has been described, it was in the 19th century in wine. And since that, the scientist is wondering, is it coming from the microbiology or is it coming from a chemistry aspect? And it's a really hard question, and we're still wondering, in fact. But in the 20th century, technot who were working on the cider in England proved that some microorganisms would produce the mousy off-flavour in wine, in the cider. And since that, we completely forgotten the chemical aspect of the defect. Not totally completed, not totally forgot. There is still a scientific team in Germany who are wondering if the chemical aspect could produce the mousy off-flavour in Neustadt. So, as I said, the microorganisms will produce the mousy off-flavour, and there is several microorganisms already known as Brettanomyces. Brettanomyces, I'm pretty sure that more than the half of you, I guess, know this yeast, because it's producing the ethyl phenol in the wine, and it's really bad, and it's your best enemy. And but we can also find some lactic acid bacteria, as Lactobacillus ligardi and also Enococcus honey. And so Brettanomyces and Lactobacillus ligardi are already described as microbial spoiler microorganisms, but Enococcus honey is responsible for your malolactic fermentation, and in general, you like Enococcus honey. So these microorganisms, when a wine is containing the mousy off-flavour, it's not directly the microorganisms who are smelling that. In fact, they're producing some different mousy compounds. I will call them like that. The ATHP, ETHP, and ETHP could be produced by the three of them, by the yeast and the lactic acid bacteria from the lysine. So an amino acid we can find easily in the wine. But the lactic acid bacteria could also produce the APY from the ornithine. These three different compounds can be found in other matrices, and they are not always bad. In fact, the APY can be found in the rice, and it's a quality marker for the basmati rice. But we can also find them in the bread, in the popcorn, in the salami, and so on. In the wine, when the compounds are present in the wine, you cannot smell them directly. You have to taste the wine in the mouth, and you will feel them by real olfaction. This thing is due to the difference of pH between the wine pH and the mouth pH. The mouth pH will be higher than the wine pH, which will allow the different compounds, to volatilize and be perceptible by the taster. And he will describe it as salami, bread, but also mouse. So I think you can imagine it's not the best dream ever. And one thing really important for us today is we cannot remove the mousy off-flavour from a wine. We cannot do it. Oh, maybe we can. Maybe we could in a few years, but now there is no answer to this question. So the principal goal of my PhD was to characterize the microorganisms, the diversity of mouse producer microorganisms in wine. But to do that, we developed before a quantification method to quantify the mousy compounds. And we also tried to determine some chemical or microbiological parameters which will influence the production. So today I'm going to talk about the characterization of the diversity of mousy producer microorganisms in wines. As I said before, only 3 different microorganisms have been described before: Brettanomyces bruxellensis, Lactobacillus ligardi, and Enococcus honey. For that, we collected 25 different wines in France to collect the different microorganisms involved and present in this different wine, and we tried to see if they were able or not to produce the mousy off-flavour in a chemical media. So for that, we worked on 25 different mousy wine, 20 red wine and 5 white wine, and coming from the east-south of France. And the first question was, are they really mousy? So we asked 10 experts of off-flavour in Bordeaux to check that before anything else. And yeah, they were. We collected from these 25 different mousy wine 353 different microorganisms, and we identified them by multi-TOF. Here I'm presenting you the diversity we found in the different mousy wine. So as expected, it's some wine, so you will find some Saccharomyces cerevisiae, but also some Enococcus because we've done the alcoholic fermentation and also the malolactic fermentation. But we're also finding some Brettanomyces, Lactobacillus ilgardi, some Pichia, some Pediococcus parvulus, and so on. So we found them, but we wanted to know if they were all able to produce or not. To do that, we worked on a chemical media containing a lot of different precursors, a lot of sugar. It's not a wine at all. You've got 50 grams per liter, and same thing for the lysine and the ornithine. And we put during 24 hours, yes, cell pellets of the different microorganisms, and we check if they were able or not to produce the mousy off-flavour. And from that, all the strain tested from Enococcus, Brettanomyces bruxellensis, and Lactobacillus ilgardi were able to produce the mousy off-flavour, at least one compound. And the other ones, so Saccharomyces cerevisiae, Pichia, Pediococcus parvulus, and so on, they were not able in this media. The next question was, okay, so they can produce the mousy off-flavour, and we can see that 33%, more or less, of the yeast collected from the different mousy wine were some Brettanomyces bruxellensis, but were they present in the mousy wine? So we checked the prevalence of the different microorganisms in the 25 different wine. And you can see here in yellow, Brettanomyces was only present in 5.1 on 25. So Brettanomyces is not the problem of the mousy off-flavour. But Enococcus, it was already scheduled that we will find it in almost all of them, so yeah. We wanted to go a bit deeper in this analysis because we worked only in with some microorganisms from mousy wine, and we were wondering, okay, so we found some mousy producers, logical, the wine is already mousy, so someone did it. So to do that, there is a lot of work showing the diversity for Brettanomyces bruxellensis, but also for Enococcus, and we wanted to see if the genetic diversity will have an impact on this production. So we worked on 22 Brettanomyces bruxellensis, 10 Lactobacillus ilgardi, and 20 Enococcus. And we checked in the same media than before, the production. Here you can see the production of the APY from the different genetic group. So in yellow, in orange, it's Brettanomyces bruxellensis. In the literature, I showed you that Brettanomyces bruxellensis could not produce the APY. And in dark blue and sky blue, it's Lactobacillus ilgardi and Enococcus. And after that, you've got different genetic groups. So ABC for Enococcus, the red one, light red and orange, ABC. And this one are the genetic groups we can find in wine or in the must. And we can see that there is no differences between the different genetic groups. Same for Brettanomyces, there is no difference. Unfortunately, Lactobacillus, we're not working that much on this bacteria, so we don't know the genetic diversity. But it seems that all the lactic acid bacteria could produce the APY. Concerning the ATHP, here you can see that, sorry, I put everything in a way. Brettanomyces bruxellensis was producing more ATHP than the lactic acid bacteria. Same thing than for Enococcusoni, you can find the different genetic groups here on this circle. And we didn't find any differences between the different genetic groups. And they were all able to produce the ATHP, the yeast, and also the lactic acid bacteria tested. We checked also the ETHP, and the only difference here is that Brettanomyces bruxellensis could produce more than Lactobacillus egardi, which are even producing more than Enococcusoni. But finally, all the strains tested from Brettanomyces, Enococcusoni, and Lactobacillus egardi could produce the mousy off-flavour in this condition. To conclude on that, on this part, because I think it's the most important thing I have to say today about the microorganisms, I will stay here. So only Brettanomyces bruxellensis, Lactobacillus egardi, and Enococcusoni, as described in the literature, was able to produce the mousy off-flavour. But Brettanomyces bruxellensis was almost never here in 20% of the wine tested. From that, we also published an article in the IVES technical reviews. No, Brettanomyces bruxellensis is not responsible for all the rules. So thank you for your attention. Thank you again, IVES, and thank you to my co-authors. The question is always here. Maybe we will find one day one yeast. We will not be able to, but yeah. So thank you for your attention. Thank you again, IVES, and thank you to my co-authors. And thanks.